When we talk about light, usually we're really talking about visible light, but really the full electromagnetic spectrum encompasses a lot more than just visible light. Put another way, of all the light that is in the universe, our eyes are sensitive only to a very small amount of light, which we call the visible spectrum. So in the visible, what we have is pretty much we have here going from in terms of the rainbow, we have pretty much purple down to red. Okay, and but if we kept going, so this is pretty much all that we can see. It's pretty much this amount of the visible spectrum, of the electromagnetic spectrum. If we go below red, what we get, the first type of light just below red, is what's called infrared. And infrared radiation is used for remote controls for televisions because we don't see them, the automatic flushing toilets, and the paper towel dispensers that you see, and so on. Below that, we get what are called microwaves. Okay, which is a kind of one narrow band of microwaves is used in microwave ovens, and we're familiar with those, and down even below that, we have what are called radio waves, and we're familiar with that because of cell phone receptions and FM, AM, FM radio, and so on. If we go above purple, we have ultraviolet. And ultraviolet light is the kind of light that you put sunscreen on to block because it damages skin. And then we have X-rays, which are so energetic they pass right through you, except for they get absorbed in your bones, and it's used for dental work and things like that. And then finally, at the very high end, we have what are called gamma rays. And you don't have generally personal experience with those, although they're produced in the upper atmosphere. So I've written it in this way, and talking about higher up and lower down. And the reason we write it this way is that this light is organized in this order based on a couple of things. First of all, going in this direction, this is increasing energy. So, all right. It's also increasing frequency. So a higher energy light has a higher frequency, which means it wiggles more times up and down per second. Going this way is increasing wavelength. So higher frequency is lower wavelength and vice versa. But it's easiest, I think, to think of this list really in terms of energy. And you can think of it in the following way. It takes a certain amount of energy to damage cells, and we notice that visible light doesn't tend to do that, but as we get higher up, ultraviolet light causes skin cancer, X-rays can cause even deeper cancers, gamma rays can damage DNA in your cells, and so on. So as you go up here, we have more and more energetic and possibly more and more damaging. As we go down here, we find that that's less and less energetic. So we have infrared, which we use for remote controls and for night vision goggles and so on, microwaves, which pretty much you're immune to, other than a very narrow band which tends to heat up water, and so it just heats up. things, and then radio, which essentially passes through buildings and people and so on, and is pretty much harmless. So this is the kind of organization that we have. Now, if we were to actually a convenient unit of energy that is used is in this type of situation is called an electron volt, and the only reason why it's convenient is because the numbers tend to be kind of handfuls when we go through this. So so an electron volt, I'm not going to go through the actual definition of it because it's not important. You can just think of it, so it's abbreviated EV, lowercase e, uppercase v. You can think of it as just a very small amount of energy. And so what we have for this range is the visible range has pretty much ranges from about 2 to 3 electron volts, with red being, say about 1.6, 1.7 eV. Purple is about 3 eV, and so on. As we go higher up, ultraviolet ranges from about 3 going up to about 1,000 eV. X-rays go from about 1,000 to about 10,000. Or actually more like maybe like 100,000. And gamma rays are pretty much anything over 100,000 eV. So anything greater than 100,000. As you go down, infrared ranges from about 0.01 eV all the way up to about 1.6, and microwaves range from about 10 to the -5 up to about 0.01, and radio waves are pretty much anything less than 10 to the -5 eV. Okay, so just to kind of give this range, and we'll compare this range later on when we look at the spectrum of hydrogen.